So hello everyone, let's start with a new topic, how to represent a graph. Okay, so today's topic is how to represent graph. So there are two methods to represent a graph. First one is adjacency matrix, another one is adjacency list. So let's talk about adjacency matrix. Okay, so wait a minute. Yep. So let's talk about adjacency matrix, how to represent a graph in adjacency matrix. So let me first make a graph. Let's say we have one here, two, three, and let's suppose four, five. These two nodes are connected, these two nodes are connected. Okay. So this is my graph. So how to represent this graph in adjacency matrix? So first of all, we make a table, simple matrix. Okay. So let's Yes. So in adjacency matrix, first of all, we declare it globally and index. Let's try to indexing 3, 4, 5, 5, 0, 1, 2, 3, 4, 5. Okay. So if we are indexing from if our indexing is from 0th, basically 0th bit is 0th base indexing. So in that we taking total number of nodes, that is n. Okay, total number of nodes, that is n minus 1. Okay, so if our total number of node is 5, then according to 0th base index, 0 base indexing, we take total number of nodes equal to 4, because 0 is also included in this. 0 to 4, basically 0 to 4, these are inclusive. Okay, so for not having confusion, we are not taking indexing from 0, we are taking indexing from 1. Okay, so how to fill, how basically input is given. First of all, we have to talk about input, how input is given. So how input is given is basically, suppose we have 5 nodes and 1 2 3 4 5 vertices. Okay, so 5 nodes, 5 vertices. Along with 5 node, 5 vertices, there are uh, if there are 5 vertices, so there are 5 inputs next to line. Okay, so there are, first input is 1 and 3, 1 2 and 2 3. Basically it represent the edges. It represent the edges of the graph, edges of the graph. Okay, simple. 1 3 1 2 2 3 and 3 5 3 5 4 5 4 5, and there is one more, 1 4 1 4. Okay, so this is the basically our input. First input contains node, total number of nodes. Second input is contain vertices and vertices along with vertices or edges, both are similar. Okay, so this is our input. So how can we fill our matrix according to this? If we are considering zeroth base indexing, then basically we have to subtract 1 from each of these input. So for now we are not taking zeroth base indexing. For that, we use two two number, basically fill the matrix. Okay, 0, there is 0 basically represent there is no vertex present between uh, ith row and ith column. Okay, if one there is a vertex, there is a vertex between ith row and ith column. Okay, simple, ith row and ith column. Okay, so let's try to figure it out. So now basically we make our array. Let's suppose our array is declared something like this: vertices plus 1. Okay, so this is our 2D array. Okay, so now let's try to fill this matrix. So first of all the variables basically set to 0. Okay, basically all the indexes of our array is set to 0. Let me fill it. Let me do one thing. Yes, so let's try to fill this box. So now our first input comes 1 3. There is a edge between 1 and 3, so we take 1 and 3, basically 1 at third row. So there is edge present, so we put 1 here. And also if there is, this is a bidirectional graph. Okay, so we also put basically what we can say, third row and first column. So this will be, let me correct it, this will be also 1. Okay, this is a bidirectional, so we have to put, we have to basically set uh, a value which is having 3 index which is having 3 1 and 1 3 1 3, because these are bidirectional. We can go from 1 to 3 and 3 to 1 also. So that's why we have to set both the indexes. Okay, similarly 1 and 2, basically if we are considering row first, 1 and 2, so here it is 1 and 2, and 2 and 1, here it is. Okay, again 2 3, 2 and 3, basically second row third column, so here it is 1, and 2 3 and 3 2, here it should be 1. Okay, 3 5, 3 third row fifth column, it should be 1, fifth row third column, third column, yep, here it is 1. 4 5, 4 and 5, here should be 4 and 5, 5 and 4, fifth row fourth column, here should be 1 1 4. 1 4 is basically first row fourth column, and fourth row first column. So this is how we fill our adjacency matrix. Okay, so if we are traversing adjacency matrix, we can see if we have 0, then there is no edge present between these two nodes, and if there is a 1, there is a node present between two nodes. Okay, so let's try to understand this time complexity. Okay, so what is the space complexity? First of all, we declare negative parts of adjacency matrix. Okay, simple. So if we have to store n nodes, so basically we have to make n cross n matrix. So basically we have a space complexity of n square, which is not good. And what is the maximum space we can utilize while making a array of while making 2D array. So basically we can consider only uh, 10 raised to power 3, 10 raised to power 3, and max to max, and max to max 10 raised to power 4. So now here it comes in basic input there is a constant of 10 raised to power 6. So we cannot store 10 raised to power 6. We cannot basically make array of 2D array of 10 raised to power 6, 10 raised to power 6. Okay, so it is not feasible. So what is the best thing about this array? uh, Basically we can say achhi baat. So what is achhi baat of this array? We can um, find the vertex between two nodes in big of 1. Okay, so this is our time complexity of finding a edge between two nodes. Simple. Okay, so this is the negative and this is the positive about this adjacency matrix. So how can we tackle with big of n square and 10 is to power 6 input constant? Okay, so let's talk about adjacency list. So now comes to adjacency list. Let's consider the same graph. Let me copy it. Yep. So let's again try to understand. Here we are talking about adjacency list. Okay, simple. So what is adjacency list? We make basically in this we make an array. Basically we can say we are making a 2D array but fixed column, but fixed column. Okay, so how let's take the same input as well. Let's take it. Yeah, so let's try to understand this, how this will work. So first of all, the input is given in this form, 5 column 5 vertices. So we make a vector array, basically vector array. So how can we make? Basically it is an integer type. It is a, let's name is graph, and having a what we can say um predefined size. Suppose 10 raised to power 3, or let it be 10 raised to power 6. Or we can basically take vector of vector for making adjacency list. So we take vector of vector. Okay, so in this way we can also make adjacency list. So let's try to understand how to fill. So suppose we have a n vertex, so n edges. So let's suppose we are taking n plus 1. So what is, it's 5 6. Okay, here we are not considering zero based indexing. We are not considering. So first of all, if we comes to once, there is an array. Okay, there is an array, there is a vector array, basically we can say. So in this array basically it's a 0 1 2 3 4. Okay, along with this it is a vector. Okay, simple. So now we are taking 5 also. Okay, so the first input comes, we push our first input along with basically along with the second edge of that input. So we push, this is a basically vector, so it will become size of 1. If we check basically vector 1 dot size, we get our answer is equal to 1. Okay, so it's simple. Now this, along with this, we have to also put our both the basically what we can say, we have to consider both the indexing. Okay, because this is a bidirectional graph. If it is directional, then we considered only 1 3 or 3 1. What is the direction of that point? Okay, it's simple. So let's try to figure it out. 1 2, again we push 1 in 1 2. Okay, again we push 2 in 1, and we have to also push 2 in 1. Okay, we have to push 1 in 2 basically. So now 2 3, we have to push 2 in 3 and 3 2. Okay, simple. We have to push 3 in index 2, we have to push 2 in index 3. 3 5, similarly we have to again push 3 5 and 5 3. 5 3, let me pick up my call. So now comes 2 4 5. In 4 we have to push 5, in 5 we have to push 4. Now 1 4, in 1 we have to push 4, in 4 we have to push 1. So now we can see that what is the space complexity of this adjacency list. So basically big of n plus m. What is n? N is basically our number of nodes, and m is number of edges. So in this adjacency list, we can store basically 10 raised to power n, which is smaller than 10 raised to power 5, and edges which is having smaller than 10 raised to power 7. So this is the more optimized space complexity. It's basically not n square. Okay, just like ADJ matrix. Okay, so now what is the time complexity of finding there is an edge between two nodes? So it's basically big of m. Okay, so big of m, where m is number of edges. Simple. Okay, so let's try to code adjacency list. How to code a adjacency list? So let's see. So let's include our header file, include bit/standard dot c plus plus dot h. Okay, using name space std. So first of all, we declare our size of the adjacency list. So it's would be 1e 10 raised to power 3. Okay, simple. After that, we declare our vector. For that, vector of array, and this is our graph. This is our what we can say, n. Simple. Okay, so this is our adjacency adj list. Okay, so now write a code, int main return 0. Okay, so we declare n comma m, number of edges and number of vertices. Let's take input m. Okay, so our next basically next lines takes the m input. Okay, so for taking m input, we are taking loop for int I is equal to 0, I less than m, I plus plus. Okay, simple. So here we are considering zero based indexing, so let's consider one based. Okay, so now how to fill adjacency matrix? First of all, we have to take input of the vertex node. So let's take input v1 and v2. These are two vertices, so let's fill this. So v1, not v1, basically graph v1 small v dot push back. What we have to push back? Basically v2. Okay, similarly we push v1 in v2. We push here, we are pushing v2 in v1. Here we are pushing v1 in v2. Simple. Okay, so this is our graph. So let's talk about how to take basically how to take if the weights of the edges is given. Okay, so for that we make a graph. We make a graph of vector pair. Okay, we make a graph of vector pair int comma int. Okay, so this is our pair graph, uh, graph 2, let's name it graph 2, and having n size. Okay, so let's again try to fill this with if the WIGST weight of the edges is given. So how to fill this? So for that, again we run a loop for int I is equal to 0, I is equal to 0, not 0 1, I less than equal to m, I plus plus. Simple. Up now for that we have to take three inputs. For that we have to take three inputs. So v1 v2, it is similar to above, and along with that we have to take input weight of the edges. Okay, so now how can we push that? We declare a graph as v1 along v1 dot push back. Now we have to push uh, push the weight along with the second edge. Okay, so let's make a pair. Here is v2, here is weight. Okay, simple. So this is basically how we make pair. Okay, so now again we do similar thing as said above. If if it is a, let me declare, this is a bidirectional graph. Okay, here it is also a bidirectional graph. Okay, for bidirectional graph we have to put both the index to set. If there is a directed edge, so basically we put in what we can say, basically if we are having node 1 which is pointing to node 2, okay, vertex 2 basically, then we have to consider basically taking input in 1 and pushing 2. Okay, so this is the logic. So right now it is a bidirectional graph, we put along with its weight. Okay, so it is simple. So this is how we can declare a graph in adjacency list along with its weight. So thank you.